As we continue looking at modeling linear data, we're going to go ahead and use some technology to help us set things up. There's different types of technology you can use. There's the graphing calculator. TI-83 and 84 are the ones that are more popular. You can see a search you can do there if you have one of those. A spreadsheet, such as Excel or something like that, some type of spreadsheet, and that's what we're going to do today. And then there's the internet. You probably could search something for some type of applet or regression app that you could plug in your data, and it would give you some of that information, probably plenty of information, even more than we're going to study today. So here is an example. Use the table, which shows the 400-meter dash winning times for each Summer Olympics since 1896, and technology, and use technology to create a scatter plot and determine the equation of the line of best fit. Use the data to predict the winning time of 2012 and the year in which the time will be under 40 seconds. So we're going to go ahead and use a spreadsheet. I'm using Excel. You can use any spreadsheet. They might differ in their formulas a little bit, but they're all going to be similar. So here's a spreadsheet. I entered all the times, or I entered all the data in here. I know it's pretty small. So I'm going to zoom this in some so we can see this a little better, but all the data is there. And let's go back and look what we're supposed to do. Use the table which shows the 400-meter dash winning times for each Summer Olympics since 1896 and technology to create a scatter plot and determine the equation of the line of best fit. So we want to create a scatter plot. So what we can do to do a scatter plot, you can select your values all the way down, and we can go to Insert. When we go to Insert, there's a lot of different charts over here and down here. This one is a scatter plot, so we can hit this and we'll choose this scatter plot right here, and there's all those data points. And so it does look like the trend is moving down. People are getting faster and faster as you look at this. So there is a scatter plot. We'll move this off our data a little bit. So that's one thing we want to do. The other thing we wanted to do was find the equation of the trend line. And so what we're going to do, in order to find the equation of a line, we need two things. We need the slope and we need the y-intercept. And we're going to find those things. So Excel's a pretty powerful program here. So here's where you can put functions. And so we're not real familiar with these, so I'm going to go ahead and put this insert function, and it brings over this bar here that we can search. And I just want to find, how do I find the slope? So here it says slope, and down here it explains what it is, returns the slope of the linear regression line through the given data points. And that's what we want. So we're looking at regression lines here. And so what we do is we're going to select this function, slope, and then it tells us we want to put our known y values first and then our known x values. So we can insert the function. You can do it right here since we use this formula builder here. We want our known y values, which are here. So we will drag down to the bottom of our table of the y values. That got me too much there. So it went all the way to D29. I only went up to B29. So I'm going to change that to B. So we got our known y values. Now our known x values. I know it's typing in some crazy things here. So I'm not going to use the formula builder there. So I want my y values, and now I need to put in my known x values, which are the 1896 all the way down to 2008. And so we can end our parentheses there, and that will give us the slope of the regression line. So I'm going to go ahead and hit enter and just scroll up a little bit. So our slope is -0.07. which makes sense because the time is dropping. And now our y-intercept. So I'm going to come here and search for intercept. And there is something called intercept. Down here it says it calculates the point at which a line, that's good, it's talking about a line, will intersect the y-axis by using best fit regression line plotted through the known x values and y values. So that's good, that's what we want. This one's set up very similar. So it looks like we can, this time I'm just going to type in and we can put equals. Anytime we start a formula we can put equals. And it's showing that we want to just type the word intercept, and that will give us the intercept, the known y values, which that was these right here, B3 all the way to B29. Again, I'm having some trouble here, so I'm going to type it in here to B29, hit comma, and then we'll do A3 through A29. And there is our y-intercept. And so our trend line, which I'll go back and write it down here, we did the scatter plot, which is there. Our trend line has a slope of negative 0.07379. So we'll come over here, our trend line, so y equals negative 0.07, I forget what the other part was, 7379, we'll go to that, 07379, 07379x, and then plus our y-intercept, which was 190 point something, 0.53. And so there's the equation of our trend line. It says use the data to predict the winning time in 2012 and the year in which the winning time will be under 40 seconds. So we're going to do two things here. One, I'm going to go back to Excel and just figure it out and show you something that you can do here. So now that we have this equation, we can use it as a predictor. And so I'm going to put 2012 here for right now. And what I want to do here is I want to find the time. Well, the time is our y value, and we know that our trend line is this right here. Y equals negative 0.07379x plus 190.53, which we could do this by hand. We could plug in 2012 and figure this out, but we can easily use Excel to do this, and we can even do more. So what is the time going to be? Well, the time is going to be the equation of that line. So I'm going to make a formula here. It's going to be equals, and we're going to type in our formula. It's going to be our slope. Remember, so y equals mx plus b, our slope, times our x value. So our x value is our time. And right now, it's going to put 2012. So times, which is an asterisk, 2012, plus the y-intercept. So this is our mx plus b, and that will give us our time. So we'll hit enter, and the predicted time will be 42.07 seconds in 2012. Well, if you remember, that's extrapolation. It's finding something outside our data points, and we could keep going. And we're like, well, we're close to 2020, so let's check what would happen, we think could happen in the 2020 Olympics. So maybe possibly someone could hit 41.48 seconds for the 400-meter dash. So that's extrapolation. We could pick something in here like 1948. See how this matches up. 1948, 46.2. This says 46.8. So that's what our formula comes up with there. So again, for 2012, the prediction is 42.07 seconds. So for 2012, 42.07 seconds. And then it also asks us to find the year at which the winning time will be 40 seconds. So now we actually want this to be 40 seconds. So what we can do here, we could put 40 seconds in here and solve, and that would give us the answer. And so to solve this, we could subtract the 190.53 from both sides. So I'm going to do 40 minus 190.53, which is negative 150.53 equals the negative 0.073. Like that wasn't right. 7379. I typed that wrong. 7379 should be in there. Oh, I wrote it wrong here. 7379 x, and we'll divide both sides by that. And we get 2039. 2039.978, so 2040. So 2040, maybe there will be someone who can run the 400 meter in 40 seconds flat. And so that's how you can use linear regression or trend lines to help you predict data.